The requirement for a bonding jumper between a meterkin and a main electrical panel arises from the need to ensure a continuous and effective path for fault current. In a 120/240 volt single-phase service, the integrity of the grounding system is paramount for safety and proper operation. The fundamental principle is to establish a low-impedance path that facilitates the operation of overcurrent protective devices such as circuit breakers or fuses in the event of ground faults. This involves ensuring that the neutral conductor, also known as the grounded conductor, is properly bonded to the equipment grounding conductor (EG) at the service entrance. The service entrance typically refers to the point where the electrical service enters the building. This is commonly at the main electrical panel. The purpose of this bonding is to create a common reference point for voltage and to provide a path for fault current to return to the source. This path allows for the rapid clearing of faults by overcurrent protection. Firstly, the grounded conductor, neutral, is connected to the metal enclosure of the service equipment. This connection is achieved through a main bonding jumper, which is a conductor that electrically connects the grounded conductor to the equipment grounding conductor. Secondly, the equipment grounding conductor system is connected to one or more grounding electrodes. These electrodes can take various forms, such as ground rods, ground plates, or metal underground water pipes. The grounding electrode provides a connection to the earth, which helps to stabilize the voltage to ground and provide an additional path for fault current. The bonding jumper between the meterkin and the main panel ensures that these two elements are effectively connected. The meterkin is the enclosure that houses the electrical meter. It is typically located on the exterior of the building. The main panel is the primary distribution point for electricity within the building. Because there is a non-conductive section of PVC between the meterkin and the main panel, a bonding jumper is needed to connect the equipment grounding conductors to ensure that the path to ground is continuous and has low impedance. In situations where a PVC nipple or other non-conductive material is used to connect the meterkin to the main panel, the bonding jumper becomes even more critical. PVC, being a non-conductor, does not provide a path for fault current. Therefore, a separate conductor is required to bridge the gap and maintain the integrity of the grounding system. The absence of a proper bonding jumper can lead to several potential problems. One significant concern is the increased risk of electrical shock. If a fault occurs and there is no lower impedance path for the fault current to return to the source, the metal enclosures of electrical equipment can become energized. This can create a dangerous situation for anyone who comes into contact with the equipment. Another issue is the potential for equipment damage. When a fault occurs and the fault current cannot quickly return to the source, it can cause overheating and damage to electrical components. This can lead to costly repairs and downtime. Furthermore, the absence of a proper bonding jumper can compromise the operation of overcurrent protective devices. Circuit breakers and fuses rely on a rapid increase in current to trip or blow, thereby interrupting the flow of electricity and preventing further damage. If the fault current is limited by a high impedance path, the overcurrent protective devices may not operate as intended, potentially leading to a fire hazard. From a code perspective, the National Electrical Code, NEC, provides specific requirements for bonding and grounding to ensure electrical safety. These requirements are designed to minimize the risk of electrical shock and fire. The NEC specifies the size and type of conductors that must be used for bonding jumpers, as well as the methods for connecting them. It also outlines the requirements for grounding electrodes and the overall grounding system. Compliance with these requirements is essential for ensuring a safe and reliable electrical installation. The installation of a bonding jumper typically involves connecting a conductor, usually copper or aluminum, between the metal enclosure of the meterkin and the grounding bus in the main electrical panel. The size of the conductor is determined by the size of the service entrance conductors, as specified in NEC. The connection must be made using approved connectors and methods to ensure a secure and reliable electrical connection. It is important to note that the bonding jumper is not a substitute for the equipment grounding conductor. The equipment grounding conductor is a separate conductor that runs with circuit conductors and connects the metal enclosures of electrical equipment back to the grounding bus in the main panel. The bonding jumper serves to supplement the equipment grounding conductor by providing an additional path for fault current. When verifying the integrity of a bonding jumper installation, several key points should be checked. Firstly, ensure that the bonding jumper is properly sized according to the NEC requirements. Secondly, verify that the connections are tight and secure. Loose connections can create a high impedance path, which can compromise the effectiveness of the grounding system. Thirdly, inspect the bonding jumper for any signs of damage or corrosion. Damaged or corroded conductors can also increase impedance and reduce the effectiveness of the grounding system. In addition to the bonding jumper between the Metercon and the main panel, it is also important to ensure that all other metal enclosures and equipment are properly grounded. This includes items such as metal conduits, junction boxes, and electrical equipment enclosures. Each of these items should be connected to the equipment grounding conductor system to provide a continuous path for fault current. The grounding system should be inspected regularly to ensure that it is in good condition and that all connections are tight and secure. Any issues or deficiencies should be addressed promptly to maintain the safety and reliability of the electrical installation. Furthermore, it is crucial to understand the relationship between grounding and bonding. Grounding refers to connecting the electrical system to the earth, while bonding refers to connecting different metal parts of the electrical system together to create a low impedance path for fault current. Both grounding and bonding are essential for electrical safety, and they work together to minimize the risk of electrical shock and fire. Grounding helps to stabilize the voltage to ground and provide a path for fault current to dissipate into the earth. Bonding ensures that all metal parts of the electrical system are at the same potential, which reduces the risk of electric shock if someone comes into contact with two different metal parts. In summary, the requirement for a bonding jumper between a Metercon and a main electrical panel is a critical safety measure that helps to ensure the integrity of the grounding system. The bonding jumper provides a low impedance path for fault current, which facilitates the operation of current protective devices and minimizes the risk of electrical shock and fire. Compliance with the NEC requirements for bonding and grounding is essential for ensuring a safe and reliable electrical installation. Regular inspections and maintenance of the grounding system are also important to ensure that it remains in good condition and that all connections are tight and secure.